Hello, hello, hello. Welcome back. Welcome back. Welcome back. Interesting development yesterday for those of you that were here. I can't run the cargo test because I'm in the middle of another change. Well, maybe I will stash this. Cargo test. So this is the test results for a number of the tests that we wrote yesterday. You can see I even still have the debugger open. The debugger, so code LLDB, for those of you that don't know, is actually kind of amazing. In this case, I was using it to debug one of these tests. But basically, if you install code LLDB and you hit debug here, it will run your test, your cargo test, with the breakpoints that you set in the editor, and it will show you all of the local variables in the top right. It'll show you the call stack in the bottom right. It'll show you the output of your test in the bottom. And you can either continue to, I think, the next breakpoint, or you can start stepping through the actual execution. And you can see, like, I just got a debug for version 4. I got the debug for version 2, or type ID 2, which came from line 110, which is the one we were stopped at. And yeah, I don't know. I just I used code LLDB to debug the Rust stuff as I was building the nom parser and the binary parser yesterday. And I was having some trouble with. So if I run the bin from yesterday, what we end up with is this attempt to shift left with overflow. So even though I have a bunch of tests that are running the full suite, right? Test B, A, B, and C over here, all succeed. Test D succeeds. But when I run it on the actual input, it doesn't. And I know exactly why. And I know exactly why, because I used the debugger to actually step through the program and evaluate what everything was at different points. And I noticed exactly when in my program the problem was happening. So if we look at lib.rs, I might still have a debugger breakpoint there somewhere. Where was I? Right. So right here on line 49, you see this offset mod 8. That used to be a hard-coded 0 when I swapped it over to be the binary parser. And the issue I was having was that I couldn't get the number of bits to match the thing that I was putting them. Oh, the U16, U32, whatever. I could only get it work for U16. The reason I could only get it work for U16 is because this offset is actually the offset of a individual byte. So when we transfer the nom parser from being a string parser to being a parser of binary data, so the input then changes to a byte slice, right? A reference to a set of U8s. Because Rust doesn't have an individual bit type. The closest Rust has is the Boolean. But we can still access the bits in a U8. So we changed take to be take a number of bits and not take a number of characters or something like that. And then the offset had to be calculated for, let's say we have if we have a U16, right? A U16 is a U8 and a U8. So we end up with a 2-element array that has 2 U8s. Which means that if the offset, so if we have 3 bits, right, those are all going to be stacked in the second byte at the right end of the second byte. So we need to skip the first one, which is what this is doing, is checking for the byte offset. And then we need to set the offset into that bit, or into that byte. So in that case, we would set it offset at 5, and then we would get the rest of the byte as bits. So the byte or the binary version of yesterday's problem works. It doesn't work on large input, which is a problem. But if you are interested in seeing that, I won't go too deep into it. I just wanted to mention that it is a thing and it is working, if not fully. There is a repo here with a pull request, and you can either track the progress or, I don't know. If you know something I don't, let me know. I think that the last thing to do in this pull request, so this is the non-binary parser from yesterday. The last thing to do in this pull request is going to be to expand that U128. If I can find it. The lib.rs is apparently a large diff, so it wasn't rendered. Okay, so the last thing that needs to happen is this spot with the 128. Actually, 128 is still too small, so a couple of my tests fit in a U16, a couple of my tests fit in a U32, the last test fit inside of a U128, but the input has an offset of 5,500. So we need to turn this into an array of 128s, basically. So we have a very large array of U8s when it comes back from take here. And that's really the last thing we need to do to make the binary parser work. So maybe I'll have that done tomorrow. I don't know. I'm getting my booster shot today, so I'm not making any promises about anything this weekend. But I can close out all of these windows. And we can see that I changed 2 interesting things as well. So in part 1, we are now doing an fs.read, which gives us a byte slice instead of a read to string, which gives us a string slice. And then in lib.rs, in process part 1, we were doing a hex decode on the bytes to go from hex into binary. And then this is just a debug print for loop. And then we can throw in the byte slice with a starting offset of 0. So it actually turned out to be fairly easy to transition from a string parser to the binary parser. And I actually found it pretty interesting. So I might make a video on that at some point. But let's look at day 17 now. Also, today we are on a time crunch. Because I'm getting my booster shot, I need to be done with the stream in 2 hours. So hopefully we can get day 17 done quickly. Let me set my alarm. All right, source, lib. We're probably going to do a non-parser. We probably aren't going to do a binary non-parser. Actually, you know what? If we just go to day 17, I was reading this problem before stream, and oh boy, is it not fitting in my head. Y'all are all saying it's an easy problem, so I'm going to trust you. And I think what I'm going to start with is just writing this step function so that I have it in my head. We have a target area that we need to fit into. I think we don't have a fixed number of steps, do we? Not really needed today. I don't know what not really needed. Because our input isn't like bounded, right? We just get a target area. And I guess we start at 0, 0. I guess we can only, what? We can only step by integers of 1. So it has to fit. There's some cool math stuff we can try after you've solved it, I think. I don't remember the equations for parabolic equations or quadratic equations or anything. I haven't had to do real math in like 10 years. At least 10 years now. I think I didn't, the last time I did actual math was like high school or something. So over a decade ago. It's all explained in the puzzle, as it is every day, and yet everybody, and yet 50% of people have a problem reading it. Okay, so we can fire a probe with any integer velocity in the x forward and y upward or downward direction. So it has to be an integer velocity, which means there's a bound on how fast we can be going to the right. For example, an initial velocity xy like 0, 10 would fire the probe straight up, while an initial velocity 10, negative 1 would fire the probe at a slight downward angle. The probe's position starts at 0, 0. Then it will follow the same trajectory by moving in steps. On each step, these changes will occur in the following order. The probe's x position increases by its x velocity. Y increases by its y velocity. Due to drag, the probe's x velocity changes by 1 toward the value 0. Due to gravity, the probe's y velocity decreases by 1. So we've got, let me pull up something to write in. Actually, let me just pull this over to the editor page, I guess. And I'll just minimize the terminal for the moment. So what do we have? We have some time step, right? Is time step we have some target area. So this will be an if whatever, whatever. You need to find the initial xy velocity values that after any step, the probe's x position is at least 20 and at most 30, and the probe's y position is whatever. And I think reading through this, like, it skips time. So like this isn't actually like an equation. We only get the time steps. We don't actually get to be like we can't be in this position right here, even though what 1 2 3 4 1 2 3 4, like we basically can't be in this middle position right here between the two dots. We can only be on the integer spots for each step. So time step and x are not the same thing necessarily, but given the target area, one initial velocity that causes the probe to be within the target area after any step is 7, 2. let me just, so this is 0, 0 then? So then we get like 7, 2 and 14, 4, but it's not 14, 4, it is, what, 13? 7, 8, 9, 10, 11, 12, 13, 3. And then the y velocity is what, like 0 at this point? So it's 13. Yeah, we're doing, are we doing this? We're doing this. 13, 14, 15, 16, 17, 18, 3, and then 19, 20, 21, 22, 22, 2, 3, 24, 25, 25, 0, 27, 1, 2, 3, negative 3, and finally 28 and 3, 4, 5, 6, 7. So this is our equation. We're not our equation, this is our series. And then this is y equals 2, x equals 7. This is y equals velocity, vy. Let me call this vy before I get super, super confused. Vy is 1. Vx is 6. Vy is 0. Vx is 5. Negative 1. 4. Negative 2. 3. Negative 3. 2. And negative 4. 1. Right? So eventually x reaches 0. Well, eventually the x velocity reaches 0 and then gets pulled back maybe. Okay, so we have the velocities. What's the velocity? The velocity is velocity the derivative? So yes, let me get this in my head and then we can continue. I really think that I'm going to end up just scrambling my head today. Let's get rid of all the stuff in here. We don't need this parser anymore, so I'm just going to get rid of basically everything in here. Process packet is not useful anymore. This is going to be in stir. Puzzle input is going to be stirs because we don't need this to be a binary parser. This is going to be a U size just to differentiate it. This is not a tuple. And this is going to go back to bytes. This can be 0. Hex says binary string, get out of here. And then puzzle input, all of this stuff, operator test. Get rid of all of my other tests for the parser. We did a ton of tests for the parser. Okay. So then what we have here is step or arc, initial position, which is a tuple. So we get the U size, and then we get the, I think it has to, I don't know what it has to return. We're just gonna do this for a second. I want to do a function that takes a time step, I guess, and returns the value, which I guess is technically, I haven't read one for part 2, read the one for part 1. Read what for part 1? Oh, the math stuff. Yeah. We have to try to reach the highest position. Yeah. No worries, Nikki. So maybe this just returns a vec of position information for the moment. Just to make this conceptually a thing. I think my problem is I don't even know what the bounds are. Because in my head, this is like, I'm having a hard time wrapping my head around the fact that this isn't just infinity, right? Like, because theoretically, we would be able to just fire this up as high as we wanted to. But we actually have to land here on a step. So maybe we can do like a time step. Bounds are where you missed. Either way, we still need to calculate everything because I'm not going to be able to come up with the equation on stream. So 0 dot 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 map time step we have the initial position, which gives us the initial velocities. Bounds are can't shoot backwards. The initial X velocity has to be positive. If your probe is far away from the target, then brake. We aren't even at braking yet. Time step. So this is going to be let's do this instead. XY. This is going to be XY for time step 0, right? Or is this, yeah, so this is 0, right? Right here. That's a negative bounds, right? Yeah, -10 and -5. Okay. So we're at 0, 0. I don't want you to format yet. Rust analyzer, let t equals, please don't format. So at 0, we are at 0, 0. At 1, we are at 7, 2. At 2, we are at 14, 4, right? But we need to not be. We need to be 2, 1, 0. Plus, so y is easy. Y is plus or I guess minus, right? These can't be U sizes. No. Why did I put a U size here? I size. So starting position, velocity times timestamp. And this is the derivative is decreasing by 1. That means if I was just doing Vy, it would be y minus time step, right? Right. So y minus 0 y minus 1, or y... two, one, and then the thing that we're at is just the sum over that period of time. So if we just calculate these as dot dot to the current time step, and then sum it up, right? Vy should now be our arc 7, 2. So that's Vy. And Vx changes based on, goes towards 0, right? Due to drag, the probe's x velocity changes by 1 toward the value 0. That is, it decreases by 1 if it is greater than 0. Increases by 1 if it is less than 0. So we do kind of the same thing, but I don't think I understand what this is saying. The x velocity changes by 1 toward the value 0. That is, if it decreases by 1 if it is greater than 0. It increases by 1 if it is less than 0. Or does not change. Okay, so it goes to 0 and then stays at 0, basically. Right. And firing downward is probably a thing that we need to handle, but we don't. I feel like we're not going to fire downward ever because we're trying to get the highest height. So I think that just doing that is going to be fine. So it's x. So the velocity in y is this sum. So like we went 2, we went 1, we went 0, we went -1, that kind of thing. So this is actually just y. Is this x? Isn't y up, down, and x left, right? Yes. Why? What did I do, Derek? Can't fire down when the target is above you. The target isn't above you, is it? Or you mean the apex of the parabola? Yeah, yeah, yeah. And then this is going to be new X, right? So this is actually just new X, new Y. So I wrote the equation for finding it at a particular timestamp. An inefficient way to do that anyway. And then we're going to need like the bounds here to determine when to stop, I suppose. And this is probably this probably makes more sense as a for loop if we're going to break. I think the X is the bound though, right? I don't think Y is a bound. I guess technically Y is a bound, but the 4i in 0 dot dot. And then I guess this is time step, right? Time step in 0 dot dot. And then we get rid of this. This whole line goes away. We keep that. This is let mute. Steps equals vec. And this is steps dot push tuple. And this is steps. So if we do this, and we do this for 7.2, I didn't give it the bounds yet. If X is greater than X upper bound break, right? Because we're past it and we can't come back. If Y is lower than Y lower bound break, because we can't come back. We can't come up after we've gone down, and we can't come left after we've gone right. Otherwise, if we're high or we're left, then we can keep going. And the 7.2 is this target area. I guess, is this our input? Do we use these? I guess not. Arc. I did low to high, right? Lower, upper, lower, upper. So if I cargo run bin part 1, something went wrong. Cool. Yeah, that's the input if you want to read from the file. I'm not reading from the file yet. I'm just printing this out. Sick. I forgot to do new X and new Y. Okay, so we ended up with 0, 0, 7, 2, 13, 3, 22, 2, 25, 0. Is this the 22, 2, 25, 0, 27, negative 3, 28, negative 7? Okay, so that gives us the brute force of like everything that could possibly be there, I suppose. So now we really just need to bound the possible input. So like the 7 and the 2 kind of thing. I don't really know how to bound them, right? We've got, I guess the only thing we have to bound them is the target area, right? So if we are at 20 and to 30, our velocity can't be higher than 30, right? If our X velocity is 31, then we pass it. And that means we go from 0 to 30. Whereas our Y velocity goes up and then down, so it can be negative 10 at some point. So right, so if we get a range from 0, 30 to, I guess, 31, right? Because we want 30. So what's the bound on X, or on Y? If X is less than min target X and Y is less than target Y? Yeah, we already did that though. You're talking about this break, right? New X is greater than upper X bound. No, you're talking about if X is less than min target X and Y is less than target Y. I don't know what target Y is. Like the X bound seems very reasonable to me because we move across at X steps, basically, right? So if we have a velocity X of 2, we go 2, 1, 0, whatever, right? So So there's definitely a higher or lower bound for X that we could use. I'm just probably going to start with 0 anyway. But for Y, the velocity that we start with, how is that going to be bounded? Is it bounded based on the number of steps? The initial velocity y can't be higher than negative the min y of the target, or we'd overshoot the target immediately vertically. Can't be higher than negative the min y of the target. You mean the lower bound? Can y'all use like words like lower bound and upper bound instead of target? So you're saying negative. So the y here can't be greater than 10, is what you're saying? Otherwise, we'd immediately overshoot because why? Because we always hit on 0? Is that the issue? Are we guaranteed to always... I guess we do always hit on 0. The fact that we always hit on 0 feels weird. I guess these are... Like, why are we guaranteed to always hit on 0? We already wrote the break conditions, Commander. Why are we guaranteed to always hit on 0 here? Because it's integers? Look at the speed immediately after 0. Which is which one? This one? -1. Because we start at 0? Oh, so because we start at 0, we always hit 0 because it'll arc. Because x is just -1, which means it's only just doing the parabola arc. Gotcha. Thank you, Derek. So we always hit 0, which means that we can't be higher than negative or higher than 10. Yeah, the upward stuff is a perfect mirror. Yeah, that makes total sense. Thank you. So when we hit 0, we can't have a velocity of... why is that abs not working? Because I put the parentheses in the wrong spot. U size. That's the wrong one. I size. Okay. So we have, hopefully, a range. It is not a minimal range, but it is a range, because we're never going to go negative, right? We're never going to shoot down, I don't think. So we've got the possible x's and the possible y's. So let's do the input so that we can have the input and maybe write some tests. Target area is this. Test input is this. So tag x equals and the dot dots. Puzzle input right here. So let let input throwaway equals tag this. And then we have x equals. X is always positive, right? So I guess this is technically like x equals in this tag. And then this will be digit dot dot digit. This is actually, I don't want to do digit here. I want to do like I size if we can parse an I size. Where's nom? Nom docs, please. I size. Can we do an I size? Nope. Can we do an I32? An I32, there we go. So we get a complete I32, and then we do this again. This is X upper bound. This is let input throwaway equals tag dot dot. Where's our input? There's our input. And then comma space, y equals. And then we do the same exact thing we just did, which we could pull out into a parser, but I chose not to here. This is y, and this is y upper bound. So here we're going to return all of these bounds, basically. And this is going to return a tuple of I32s, I guess. So puzzle input, so let these equals puzzle input unwrap, because we need this to pass. These need commas. And this needs to be input and then the extra tuple. Dang, I just had this weird craving to like be in Italy eating pasta. I don't know why. But the pasta there is so good. Random thoughts. So that should be everything. And then this is 0 to the upper bound. And this is 0 to the absolute value of the y lower bound. And then we need to iterate over all of these combinations, right? How do we do that? We have those two. I don't want zip. I want like Cartesian product. Is that the right thing? itertools has that. So we could do itertools, Cartesian product. And the only reason I know that this exists is because I've used it in Advent of Code before. Unpopular opinion, I never liked pasta. You don't have to like pasta. It's totally fine. You know? Yeah, two nested for loops. Who wants to do that though? So basically you see like we have a 0.2 here and then cars here, and we get all of the combinations of both of them. Plus, this way I don't have to worry about getting the indexes correct. It'll just combine all of them because we already have all the values. I really like, I will never hate on anybody for writing the nested for loops or something like that. But I really prefer to remove the possibility of my own programmer error when I can. So if I have to pick indexes and stuff like that, then I don't want to do it. If I have to manually maintain something versus just calling a function, then I don't really want to do that unless I have like performance reasons, or if we don't want to use the dependency for some reason because we're trying to get a really small WASM binary or something like that. But given the option, I would heavily prefer to do it this way. What's wrong with arc? Because we take I sizes in arc and we need I32s? Can we not sum an I32? Let's start with this problem. Expected two arguments got 50 bajillion. Ooh, what's the problem there? X and Y? X and Y, expected I size found I32. I thought I changed the signature for an I32. Oh, I did not. That's why we're getting the other sum error here. Okay. Our parser is failing because I didn't bring in the test input. So brief overview. We have a range here from 0 to upper bound and a range here from 0 to lower bound, which means that we have two ranges here that we need to get all of the points on the graph which have an X value from the possible X's and a Y value from the possible Y's. To do that, we could use nested for loops or something like that, but instead I've chosen to bring in this Cartesian product function because it removes the possibility that I'm doing something wrong in the nested for loops. Even though Rust's nested for loops would be for X and Y, which are much more usable than, say, index-based for loops, the Cartesian product still expresses the meaning of what I want to do better. So when given the option, I want to pull in this itertools function, which will give us the combination basically of all of the x's combined with all of the y's. How many zeros in a bajillion? Million is 6, billion is 9. A bajillion. It sounds like you're saying billion and then, I don't know, is there a J version of something? Okay, we've got about an hour. Let's see, possible map. Then when we map over this, how do we find the one that we care about? We need to find... So let's arc here, right? Dot iter. Dot max by key? Is max by key the thing we want to do? Because this is going to return us tuples. Actually, we don't want to do max by key yet, do we? We want to make sure that this actually hits. So in these arcs, we want to filter for the arcs that have an X I'll use target because y'all got that into my head. X lower bound dot X upper bound, because these are guaranteed to be positive, right? And then let Y target equals but these are going to be negative, right? Can we can't do a range from negative to negative, can we? Not Rust Adventure, Rust Playground. This is an experiment I was doing for the binary stuff, actually. For what? What was I doing? I lost my train of thought. We get all of the arcs for all of the starting positions. Range on negatives, yes. So negative 10 eye size dot negative 5 eye size, right? I in, and then debug I, and if this works, then this works, and if it doesn't work, then I don't know. We can't do ranges, and we got to do it manually. Oh, it works. I guess we can't just go negative, right? So hang on, Rust Playground. This is, by the way, a really interesting debugging tool because Rust Playground basically replaces kind of like having a REPL or something like that. Because if you're just on your phone or your iPad or your laptop or whatever, and you don't want to spin up like a new Rust file or something like that, which can feel tough at sometimes, feel like a lot of work, then you can just go Rust Playground, play.rustlang.org, and you can just start typing and running and formatting and linting and doing a whole bunch of stuff. So if this breaks parallel, then we're still good, right? Yes, cool, great. That's exactly what I want. arc.find xy. X target dot contains this is any. And y target dot contains y. Right? We need to iter on this, but that's fine. Okay. There we go. Now we don't have yellow on the whole thing. We only have yellow on the variable name. Okay, so we've generated all of the positions for all of the possible arcs. We've filtered them down to just the arcs that hit. And now we need to dot max. Is it max by key what we want? Rust iterator max by key. Come on. Max by. Let's just go with max by for a second. Max by comparison, max by key. Max by key returns the element, gives the minimum from the specified function. So we get to return a value here. I think that's what we want. Max by key. Arc.iter.max by key. What is this? X and Y. So we don't care about X here. We only care about Y here. So we are going to return Y from this. We're going to unwrap because we need to have a Y. I think, wait, max by key is an option, right? Yeah. So if we iter on the arcs, that gives us a tuple of all the positions. We get the maximum position, which we still need to get the Y value out of. And then we use that, we use the max position in every arc to determine which one has the highest arc. And then that's the one that we get back. That's not arc, that is result. I didn't pull in the, I did pull in the test, okay. This test is what number do we need here? $45. So we actually are just looking for the highest point anyway. There's 45. So we found the right one. We just need to right, max by key, result.iter, result is sum of a vec. Why is it sum of a vec? I guess it's some, oh, it's sum of a, okay, yeah. Result needs to be a thing, so we're going to unwrap that. Then we're going to iter over it. We're going to max by key. We're going to unwrap that. And then we're going to get the Y value. And we actually need to return that value here. I'm going to leave a comment that says get max y value. And that is wrong because I'm going to go with types. Yes. Correct answer. What is wrong with my Rust program for 500 is what is types? The return value of this is going to be I32. We're probably, I don't know if we're going to need to bump that. I32 was just the easiest to work with at the time. So let's get our input. Is this code, but with that max by key replaced? Your part 2 will be a breeze. I'm excited for part 2 to be a breeze because I don't feel like my brain is working good today. And it's only going to get worse because I'm getting my booster shot later. So oh no, I left the debugs in. Why did I leave the debugs in? Hopefully that's the right answer. If it's not the right answer, I'm going to be sad. Big sads. Yeah, it's the right answer. We win. We brute forced it. The math stuff would be much more fun, I think. But I do also like the way I do like iterators. I love iterators. Iterators are wonderful. If we need to brute force something, we can just get all the values, write a small function to calculate the value, and then use that function in a chain of iterators to do what we want to do. Realistically, if I was going to leave this code somewhere or like ship it to production, I would have to comment this. It doesn't, like, you can read this and be like, okay, we're iterating over the arcs. We're looking for any value where the X target contains X and the Y target contains Y. But I don't think that's enough comments. I don't think this, like here, this would need to be like filter out any arcs that don't hit target, right? Because that's what we're intending to do here. To be frank, even with the math, I think all my part 2 solutions will do is have a tighter bound on the iterators. We can also have a tighter bound on the iterators here. We don't need to start at 0, right? Because there is the X drags. So I think there is a point, if I could think in my head, there would be an algorithm to determine what the minimum X would be given a position, right? Because if you start at 1 and we have a X lower bound of 30, it doesn't make it. It only goes to 2 and then stops, right? So there's a number in there that is our lower bound that we could do, but is not, I'm not using. Okay. Maybe a fancy trick shot isn't the best idea after all. Aw. After all, you only have one probe, so you better not miss. To get the best idea of what your options are for launching the probe, you need to find every initial velocity that causes the probe to eventually be within the target area after any step. Didn't we just do that? Yay, brute force. In the example above, there are 112 different initial velocity values that meet these criteria. How many cause the probe to be within the target area? Literally, like, seriously? Did we already solved part 2 because we did the brute force? That's kind of disappointing, I'm not gonna lie. Let's be real clear here. I love that. I love that for me today. Today I needed it to be something that I didn't need to deal with. So we're looking for all of the initial velocity values. So this will filter all of them that don't have any that hit the target, but that's not really what we want, I guess, right? We want to flat map this. We'll take the arcs, The arcs will filter down to XY, where X contains X and Y contains Y, which gives us all of the positions. Result unwrap dot length. So result not. Right? What is result now? Rust analyzer, please tell me what I made result. Flat map. Oh, it's count on iterators. Which means that this is what? Why is this complaining now? Returns a value referencing data owned by the current function. Does it? X and Y? Arc. Iter, filter. Arc. What did I do? Can we just take ownership of the data? Take our destiny into control? I still didn't remove the debug. Rip. Let's remove that debug before we run the next one. And let me set up the test for part 2 just to make sure that we are actually getting a thing that works here. So let's cargo test. And then part 2 panics, we get 20. We need 112 different initial velocity different initial velocity values. How many distinct initial velocity values cause oh. Oops. It's not the actual spots, so it's actually just this count, isn't it? Where's our part 1? I'm gonna go grab the stuff from part 1 because it's just this filter. It's not actually the flat map. I was trying to pull out all of the places at which we hit the target. But actually we just filter them all out. And then dot first. It actually doesn't even matter. Right. That only gives us 19. Is that because I'm going from 0? Apparently, we can go negative too, right? So that's not great. Where's process part 2? Process part 2, we go possible x's, we limit them to 0, so I think that's what we need to handle. We can also go negative on y though. So we can go from what, the y lower bound to the absolute value of the y lower bound, and x's still need to be positive. So this is the actual search space, 86. Closer. We can't go negative on x. Maybe we print these all out and I compare and see which ones we're missing. This is gonna not do what I want, but I'm gonna do it anyway for a second. A vec of what? Don't cares? A vec of don't cares. Doesn't look like Russ is going to be happy with trying to figure that out. Oh, actually, I just missed a bracket. Use after move, which we could fix, but I chose to fail at instead. Okay, so this is all of the count. This is all of the arcs. So let's do one more thing here. Let's do that map point. Actually, let's just do, yeah, dot map arc dot first. I guess just dot next, right? And then we got a vec of eye sizes. And if we flat map this, then we get that, but we can do this. Cannot build, right, not eye size. I forgot I removed eye size from the equation. How about that? Fine. We'll clone it. It still references because I'm silly. We're going to take ownership with into iter, and that'll fix our ownership issue. Okay, there's a lot of 0 in here. We don't want this. We want next. Into iter.next. Let's do into iter. Mute it equals this. It.next. And we're going to throw it away. It.next. And we're going to pass that one as the return value. So this is a bunch of points and stuff. So let me grab this. And the comparison here is going to be super annoying to deal with. 6-0, 6-1, 6-3. This isn't sorted. That's really annoying. Is it not? Yes, it's completely unsorted. Holy. That's annoying. Why couldn't they have done like all of the Y's or all of the X's or something? You just randomly jumble them up. Let count equals this because actually that's just going to be collect, right? Results. That's going to be results dot length. Sort it with the Rust playground. I could. Let me fix this value here, 112, so that when the test actually does pass, we get what we need. So we're missing about 40 values. What are we doing here? Time step. Oh, you know what? We don't handle the negatives here. Remember this comment that I wrote earlier? So Actually, we don't have to handle negative x's. Never mind. This already works. I don't think that's a valid comment. We're generating the possible input. Are we generating the possible input in the best way? This is part one. Let's go to part two. Part two. 0 dot dot equals x upper bound. Does every x only have one y? Does it matter? It does not if we're doing the highest arc, right? Are we breaking on that condition? I didn't think so because we did the highest one before. Let's see. Cartesian. Let's go back up to arc. Arc generates us time step from 0. So we start at 0, 0. We keep going. If the new x is greater than the x upper bound and new y is lower than the y lower bound, then break. So I think we just keep pushing them in anyway, so we're good there. But we don't have... How did we solve part one if we weren't generating? Let me fold part one so I don't start modifying it randomly. 0 to upper bound, lower bound to upper bound. Actually, it's the max of the y lower or y upper, right? Because what's our test input? Where's our test input? So we've got -10 and -5, but if y is 5, that doesn't work. That's fine. Yeah, if it's -1 for the lower bound and 5 for the upper bound, what we're doing is we're going from -1 to 1. We're not going from -1 to 5. So it's going to be whichever one is lower here. Rust comp. So it's going to be match. Y lower bound is always a lower. Match y lower bound dot comp y upper bound. And I think this needs to be dereferenced, or it needs to be, or I've missed a comma or something. Fill match arms. So if you have never used CMP, CMP is really interesting. Let me pull this down for a second because it's weird. Let's do new upper bound equals this. Right? What did I do wrong here? Hang on. Before I do this, I-32 cannot be dereferenced, so we just need that. Yet if we do that, then you get angry. Why did it change from... Oh, I guess the upper bound isn't what we were using before. Okay, that's fine. So so if you haven't seen CMP before, CMP is like the comparison operator in Rust, right? We could do like an actual greater than, or an actual less than, or like equality or something, but it's powered by CMP, and CMP is compare. So in standard compare, we have this ordering enum, and if we compare one value to another, what we get back is whether it's less, equal to, or greater than as an enum, which means that now we can do whatever we want. So if we need to tell if they are negative or not, so let's do abs.comp this.abs. So now we're comparing the absolute values. So if the lower is less, then we do y upper bound.abs. If they're equal, then it doesn't matter. So we just return one. If it's greater than, then it will be the y lower bound. And in this way, we can use standard comp ordering, which I will pull out and I will import ordering instead. So if we match on the lower bound absolute value, so if we have a negative, we get positive, and we compare it to the upper bound absolute value, so they're both positive numbers now. If the left-hand side is less, then we use the right-hand side. If they're equal, it doesn't matter. If the left-hand side is greater, we use the left-hand side. And we always take the absolute value because we're doing an upper bound here. So that's comp, which is really nice and useful. And I find writing... Have you ever written a sort algorithm in JavaScript and you had to write like 1, 0, or -1, and you can't remember which thing is which or how to write that? This fixes that problem, which is really nice. We still don't get the right number though. So we're possible y's, y to upper bound. So let's debug possible y's. Right. Is -10 to 10 in our case. What did I do wrong? What did I do? So we've got 0 to 30 inclusive and -10 to 10 inclusive. We can't go negative with x. We have to go from the lower bound because the most direct shot we can take is from 0, 0 to like 30, -10. So 30, -10 would be a valid shot. X target and Y target. Are the targets correct? X target is the lower bound to the upper bound, and Y target is the lower bound to the upper bound. any of the points needs to fit in the target. This isn't like... This isn't the problem, is it? So 0, 0, 30, 10. -29, -9 is valid. Yes. 29, -8 is valid. Yes. So 29, anything 29 is basically valid within the range of Y. So this seems fine. 21, -8, like all of that stuff is fine. All right, let's do the sort. Let's go drag our butts over here. Got 20 minutes to find out where I have my current typo. This is so annoying. Why did they format it like this? This is the part of Advent of Code that I dislike the most, I think. Other than, like, it fits into the same category of problem as, like, the problems being described weirdly or in an unreadable way. It's like the not supplying input in a way that is usable. Okay. Okay. So we've got all these tuples. This is just going to be a vec of the tuples. We're going to use iter tools. Iter tools. We are going to let points equals this. We are going to points.iter.sorted .collect. Well, let's just print them out, I guess. For point in points.iter sorted debug point. Then we run this. And we get the whole shebang. Actually, you know what I'm going to do first? Points that lang. I'm gonna sanity check myself before I do this. I need a better phrasing for that action. 112. Great. Wonderful. That's what we want. So let's grab this. We'll pull it into VS Code, and I will split here, create a new thing, and do this. I guess I should print it out. Six, 7, 6, 8. There was that pop sound again? What pop sound? Six, 8, 6, 9, 7, 1, 7, 0, 7, 9, 8, 2. We're missing 9, 0. And we're missing 8, 1. We're missing the Y end. How do I unsplit windows? Command Option 1 or something like that? Like Command Shift Option 1, Control Option 1. Forget what the short code is for this. Put editor right. What's the thing? View, editor layout, single. Did they get rid of that shortcut? Okay. In any case, we are missing the last Y. So I'm wondering if we're cutting it off somehow. Patatas del Papa. Hello. It's going okay. Finishing up part 2 for Advent of Code Day. What are we, 17 right now? I've got a problem where for the last array, I brute forced day 17, generated all of the possible entry or initial points. The points that I have don't match up with the final. And I am missing specifically, it seems, the last Y value, or the highest Y value for a couple of them. So 7, 9 here. So specifically, I'm missing 9, 0. So I want to debug 9, 0 if we can find it. If x equals 9 and y equals 0, debug here. Right, and we're just going to follow this one through. I need to get rid of the other debugs, I think, though, because they're going to be super noisy. Okay, so we do this. Do we see here? We do see here. So let's let result equals arc. Let's debug result and make sure that we have the accurate results. And then we'll return result here. But we only want to debug if it's this. Use after move because I keep forgetting to put the reference on when I debug. Okay, so we end up with 0, 0, 9, 0, 17, -1, 24, -3, and 30, -6. So 30, -6 is a valid spot. And we've constructed the target range to exclude 30. Is the story that's developing in my head. Yes, we have definitely done that. We did it for part 1 and part 2. So part 1 has a bug. Where's the target? X target equals, that's our bug. And we're good. That was annoying. Let's get rid of all this other debug stuff. So just a simple mistake of not using an inclusive range for the target. Just wasn't quite paying enough attention. Let's do cargo run bin part 2 while we're doing this. 2709. Hopefully that's the right answer. After all that debugging, I would hate for that to be, yeah, gold star, we're good. Those types of bugs are the worst. I can waste hours debugging errors like that. Yeah, and I feel like they pop up very often in Advent of Code where it's like, I don't know. I feel like they pop up a lot more often in Advent of Code than they do in other other situations where I'm programming. And like I write a lot of code, so but yeah, that's it. That's that. That works. We basically used the exact same code for the 2 days, or 2 parts. Just fixed the... I don't know why it worked for the part 1. I mean, I guess I know why it worked, but because it's in the middle and not at one of the edges. So we'll run the heap, the dat heap profile, and we'll run the cargo bench stuff. And then I think I'm out of time after that. Again, I am getting my booster shot today. So I am going to try to stream tomorrow, but if I get whacked out by this thing and I can't get up, then I can't get up. And then part 2, 6 megabytes, 7 megabytes, 8 megabytes. These are not great numbers. But we are doing a lot of number generation, and we are using numbers that are I32s. So, you know, there may be a way to pull this down, but I don't know that I'm too worried about it. I don't think the refactoring is going to be particularly instructive. It's going to be like, how low can we go? I just got my booster shot 3 hours ago. How are you feeling? Yeah, Derek, if you do a write-up on the math stuff, I'm also happy to come back and revisit it on stream, like tomorrow or whatever. I just don't have the time today. So far, so good. Nice. I hear a bunch of people like kind of aren't affected by it, and then a bunch of people are like sick all weekend. So we'll see. Our run times here are milliseconds today, which is slower than anything else that we've ever run. I attribute that mostly to doing a brute force approach. Probably not pulling down or not scoping our possible values enough. We're running a fairly large brute force compared to what we should be doing or could be doing. The other thing is there is a more mathematical approach that probably gets us into an even smaller bound or an analytical kind of exact answer. So we probably could bring these runtimes down if we use the better algorithm or if we scoped in our input a lot more. But I'm okay with this. A couple milliseconds is, you know, my CPU has a couple milliseconds in its cycles to run. So I think that's it for today. And oh, I did this on the binary branch. No. Oh well. If you're interested in the binary parser is up in the PR. I am also going to try to finish the binary parser today. So the string parser for day 16 that we have works. I switched it from operating on string slices to operating on bits and binary data rather than strings of ones and zeros. So I'm super curious to see if this kind of improves our memory usage or anything. I actually don't know. But the interesting part, the really, really interesting part from the binary stuff from yesterday is that the input is no longer a string slice. It's a tuple of a byte slice and a byte offset. So the byte offset is the offset into the first byte that we are at, and that resets over and over and over. And everything else just kind of works, right? Like I didn't change any of the combinators that I'm using. I changed the imports for tag and take to the bits combinators instead of the bytes combinators for possibly obvious reasons, because, you know, we want to take bits or we want to take bytes. But yeah, so I should be able to finish this as well today, and I will probably talk about it tomorrow, provided I finish it and provided the booster doesn't knock me off. So thanks for hanging out, everyone. Appreciate it. Hopefully, same time tomorrow.